Hi mathematicians, and welcome to another Unit 5 vocabulary video. This time we are going over Unit 4, which is on SAS or SAS congruence theorem. Once again, some of the vocabulary words may be similar to the ones prior, but my explanations may not. So I'm going to quickly review what I've already explained in other videos and then get on to our new vocabulary words. First up in our vocabulary terms is congruent. Remember, congruent means same shape, same size. We can talk about the whole triangle itself. We could talk specifically about angles and sides. Here in our example, we've got a congruent figure. These two triangles are the exact same. That one's just been made a copy and slid on over next to it, okay? But down here, we do not have the same shape. We have the same size, not the same shape. So therefore, these two triangles are not congruent. Corresponding parts. They stuck with corresponding parts. They are the sides and angles that are the same in the relative position between the two figures, okay? So I've talked about looking at tick marks and angles to confirm that we are talking about a corresponding side. How do we know that these are both corresponding sides other than the fact that they are labeled with a tick mark? We also need to look at the fact that it is sitting with the blue angle on its right and the yellow angle on its left when you're looking at it, right? The fact that those are the right direction, in that if we were to walk around this triangle and we go tick mark 2 blue, tick mark 1 blue, tick mark 2 red, tick mark 3 yellow, right? The fact that these are in the same order, that means that we know that side 1 is corresponding to side 1, angle blue is corresponding to angle blue, so on and so forth. Up next, the CP-CT theorem. Once again, this means corresponding parts of congruent triangles are congruent. So we've just talked about how angle or side 1, those are corresponding. I'm telling you that these triangles are congruent because they are congruent triangles, because these sides are corresponding. That means that they are congruent also. Same shape, same size, corresponding, all the good stuff, okay? Up next, we have rigid transformations. I've said it once, I'll say it again. There's 3 types of them: translation, reflection, and rotation. We can translate, reflect, and rotate as much as we want. The shape is going to stay congruent, the exact same, okay? And the new vocabulary word, side. Oh, no, not new. Oh, man, it's not new. We just talked about side, side, side. Our new one's side, angle, side. We'll talk about that here in a second. Side, side, side congruence. If you want me to go into more details, make sure to watch the last lesson's videos. But ultimately what it's saying is if we have 3 corresponding and congruent side lengths, the entire triangle is congruent. So when you're seeing a shape like this, and if we walk around the shape and everything's in the same order, all the sides are the same, beautiful, we have 2 congruent triangles, okay? Oh, now do I get to teach something new? Let's see. Midpoint. This is actually not new, but it's new as in the fact that we have not talked about it in 4 or 5 weeks. So the midpoint is the point that is exactly in the middle of a line segment. So if we're looking at this line segment here, okay, AE, C, that point C cuts it exactly in half, okay? Why does this matter? We'll go into a little bit more detail when I talk about the lesson, but if this is cut in exactly in half, that means that AC and CE are the exact same length. So if this whole thing is 4 units long, that means that each one of these are 2 units. If they're both the same length and the same measure, that means that they're congruent. And this is also important when we're talking about this shape because C isn't only the midpoint for AE, but it's also the midpoint for BC, and CD. So when we're looking at this, once again, that midpoint is telling me that these are exactly the same measure, whatever that measure may be. They're the exact same measure. So looking at this picture, because C is the midpoint not once but twice, AE is the same length, and then we have AC, CE, and then BC and CD are all the same. And then we have this beautiful side angle side congruence that we'll talk more about. Up next, included angle. You'll notice that this word is actually not on the list of definitions, but I want to make sure you understand what it is because you are going to hear Miss Simon and I constantly talking about it. What is an included angle? An included angle is an angle that is placed between two sides. Okay, so the included angle is the angle between AB and BC. Why is this important? Because when we're talking about SAS here in a moment, we're talking about side angle side. And so when I am talking to you about, is this triangle congruent by SAS, right? We could say yes, because we know the measures of AB are congruent to whatever my other one is. The measures of BC are congruent to whatever it is, and that the included angle are congruent. The included angles are congruent. And I might sometimes ask you, what is the included angle? So make sure that you take note of what included angles are. Our new vocabulary word, we have SAS here. SAS congruent theorem, side, angle, side. Side angle side states that two triangles are congruent if they have two congruent sets of sides and two congruent included angles that are all corresponding. So let me actually read it from the definition. So if you have one pair of congruent angles between, that's the included part, okay, included. So if you have one pair of congruent angles between two pairs of congruent sides, then the triangle is congruent. So our picture does a beautiful job of representing this. In this case, what it is saying is our first side, PQ and WX, they are congruent, okay, marked by the tick. Angle Q and angle X are congruent, marked by, this time not a tick mark, instead by a angled marker line. Side note, we give it as many ticks as we need, or as many marks as we need. So this is saying angle Y and angle S are congruent. Anyways, so we have PQ and QX that are congruent, Q and X that are congruent, and then we have, XY and QS that are congruent because we have a side, an included angle, and a side that are all congruent to each other. That means that PQS and WXY are congruent triangles. If you want more support videos on how to, watch the following video regarding the lesson itself. I also just want to briefly bring up again reflexive property. Reflexive property, we'll get more into this when we're talking about angle measures. Right? Sometimes our angle measures, sometimes it'll be a perfect bisector. Remember what bisector is, cut it exactly in half. Sometimes we might talk about alternate interior angles, things like that, but just remember that reflexive property guarantees that AC is equal to CA. They are the same line, and figures are congruent to themselves when we are reflecting across the line. Alrighty guys, that is the end of this unit's vocabulary words. Thank you so much for listening, and reach out if you have any questions. Until next time.